Check 1, 2, 3. Okay. Okay, so here we are. We are going to our first topic here in the chapter 9. So this chapter is about the metal. Okay. Now the first subchapter we're going to discuss is about the properties of metal. What are the properties? Properties are things that is able to let us understand, let us identify an object. Okay. So an object with properties, we can identify now that is something. Okay, like your name is your properties. So if you know a name, you know, oh, this is the object that we mean. Okay, so there are two types of properties in chemistry, and the first is the physical properties. Physical properties are things that can be seen, can be measured, can be checked physically. It doesn't involve any chemical reactions. In total, there are 4 properties that we need to understand about the metals. The first is the thermal conductivity, which is the ability to transfer heat. Okay. We use this thermal conductivity to distinguish between what is metal and what is non-metal. Now, in general, metal will be a good thermal conductor. They will be able to transfer heat well. Okay. While non-metal is a poor conductor of heat. Okay. So, if we want something to transfer metal, okay, we're going to make them, if you want something to transfer heat, we're going to make them out of metal, okay, such as the heat sink, or if you most cooking utensils. Okay. But if we want something to not conduct heat, we are going to use non-metal, such as insulator for a refrigerator, okay, and insulator and gases for gases to separate between inside and outside of a house. This is especially important, the non-metal as insulators, in colder countries. Okay, but there will be exceptions, and we're going to put in the remarks. Okay. Most non-metal is poor, but there are several good thermoconductors of non-metals. Graphite is good. Okay. We can put graphite almost to the same level of metal, but diamond is great. Actually, it is the best thermoconductor, 5 times about the best metal conductor we can have. Now, the second properties that can distinguish easily between metal and metal is the electrical conductivity, which is ability to conduct electricity or ability to transfer electricity. Metal in general is going to be good, which is the reason why most electricity carrying devices, okay, like such as wire, made up of metal. Okay. And non-metal in general is going to be bad electrical conductor, or we call them insulator. Okay. Of course, there will be exceptions. About the non-metal, graphite, again, is going to be a good electrical conductivity. In fact, okay, we have seen some specially tailored graphite, we call them graphene, made up into electrical conduit for electricity. Okay. Diamond is still a bad electrical conductivity, even though it is a good thermal conductivity. Most of the time, the thermal and electrical conductivity goes hand in hand. If something is good in thermal conductivity, it's also good in electrical conductivity, and vice versa, okay? With the exceptions of diamond. Good thermal, but poor electrical conductivity. Okay, now the next properties we're going to have is malleability and ductility. Okay. What's malleable and ductile meaning? You can see them here, but it's not in the syllabus, so we don't need to get out too much into that. Okay. We need to know that metal is malleable and ductile. In short, malleability and ductility means ability to be deformed. Okay. So we can deform them with physical stress without breaking up. Non-metal will be non-malleable and also non-ductile. Together, we call this brittle. So non-metal, if we give them excessive force, they are going to break instead of deform. Metal, if we give them excessive force, they are going to deform. Now, there's a link here for a good YouTube that you can watch on your own for more explanation. The last properties that can be used to distinguish between metal and non-metal is the boiling point and melting point. In general, metal is going to have high melting and boiling point. That's why most metal, we're going to have them in solid condition. They don't even melt, let alone boil. Sometimes we can see some metal with low melting point. So with low fire, okay, we see them being liquid. But quite very seldom here that we ever see metal boil, turn into gases. And if they do, be careful, because metal vapor in general is harmful. Okay. Non-metal, on the other hand, tends to have low melting and boiling point. Practically all gases, okay, we see them here, are non-metals. Not all gases, we have them here, are non-metals. It's because they have such low boiling point that even at room temperature, they already boiled, we get them as gases. Okay. Of course, as usual, there will be general exceptions. Okay, this is the general trend. For the metal, the exception is the mercury. It has such a low melting point that we see them as liquid at room temperature. But mercury still has quite high boiling point. Very seldom we ever see mercury boils. But be careful. Liquid mercury, they are going to emit even just a low amount of vapor, and hence we should be careful about them. About the non-metal here, most non-metal has low melting and boiling point, except for macromolecules. Okay. Macromolecules of non-metals, okay, they're going to have a high melting and boiling point. A very good exception will also, as usual, being carbon. Okay. Carbon macromolecules, such as graphite and diamond, will have high melting and boiling point. In fact, diamond is again, besides being the hardest substance known to human, it is also has the highest melting point. It actually it doesn't melt. Okay, they are going to decompose and turns into gas. Okay, so that is the physical. All of this here did not involve any chemical reactions, so we call them physical properties. Now we go into the properties, which is chemical properties. Okay, that is the reaction that they can have. Okay. There are three reactants that we usually use to distinguish between metal and non-metal. The first is the acid, okay, and this is water or the steam, and the last one is the oxygen. Okay. Let's deal one by one. Okay. Now, reaction with the acid. Metal plus acid is generally going to give us salt and hydrogen gas. The salt is usually has solution instead of precipitate here. Hence, the metal is going to be dissolved. So we're going to see the metal as if they disappear. They don't, they just dissolve and become a solution. Okay, exceptions. The metal here, you're going to see them with asterisk. Okay. There will be a class of metal. We call them noble metals. They will not react with acid. Okay. By acid here, we mean the normal acid. Okay. Like hydrochloric acid, nitric acid, and sulfuric acid. These five is the noble metals from the least to the most noble. Platinum is generally taken as the most noble of metal. Nobility means resistance to reaction in this case. Okay. Just like noble gas. Noble metal, also we call them noble because they resist reactions. Okay. Now, the most often used question is about the copper. Okay. Be careful, copper will not react with acid. Okay. It's going to stay as it is. Okay. The thing I put in red will be things that is good to know, but it's not in the syllabus here. I say here the acid, but this is the normal acid. Okay. There are special acids that is so strong they can react even with the platinum and gold, the most noble of all metals. We call them aqua regia. More of them later about the chemical trivia. Okay, next we have the reactions with water or steam. In this case here, think of steam like a very hot water. So hot, it becomes a gas. Now, water in general is not a reactive substance, unlike steam, unlike acid. Acid is a reactive substance. So, most metal, even if they are unreactive, they're going to react with them. Now, water is a very non-reactive substance. If something reacts with water, it's because that substance is going to be very, very reactive. Okay, now sodium and potassium in group 1, okay, they're going to be the most reactive. The group here, they're going to react with water, okay, but the speed is going to increase as we go lower in the group. So sodium, they're going to react fast, and potassium even faster. Okay. You can see some videos on YouTube about reactions with things that is even lower than sodium in the group 1 periodic table. Just to know, they're dangerous. Now, group 2 is not as reactive as group 1. Okay. But as we go down the group, they're becoming more and more reactive. Magnesium is the weakest, that still react. Okay. Now, magnesium, they react with water so slow, okay, it is usually not worth it to wait for it to react. If we want to react magnesium, we usually going to react it with steam instead of water. But calcium, this is the metallic calcium, not the calcium ion, they do react with water with sufficient speed, a sufficient rate. Of course, if calcium reacts, then elements lower than calcium will also be react and even faster. Now, there are a little bit difference between them here. The same thing about the reactions with acids and water and steam is they're going to produce hydrogen. Okay. Just think of water as being a special acid. Acid with the other part being a hydroxide ion. So when you react metal with water, instead of metal and an ion, which we call them salt, we get metal and hydroxides. This, generally, we're going to call them base. Okay, now, the metal and steam, it's a bit different because they're going to have metal oxide instead of metal hydroxide. So you can think that the metal here, they're going to steal the oxygen. The metal oxide is going to be solid, by the way, instead of being liquid. Oh, here, the metal hydroxides, it's going to be aqueous. Now, the last topic, the last items we're going to have is about the oxygen here. Most metals can bind with oxygen here. I say most again, right? Because there are some metal that is refusing. In chemistry, oxygen is a reactive species. Okay. Oxygen as itself is actually an unstable substance. Oxygen will be more stable if it reacts with and binds with some other elements. Oxygens bind with themselves, becoming the pure, the gaseous oxygen we know here, because it doesn't have any choice. Okay? Oxygen, chemically, we can think of them being, they hate to be neutral oxygen. They want to steal electron from other atoms. Okay, now, about the oxygen here, the more reactive metal, they're going to react faster with oxygen, and the bond is going to be stronger. If the bond is stronger, it is harder to break. How do we break bond between metal and oxygen? That's going to be topic for another subchapter. For now, we know that the stronger the metal bond is, the harder to break. Of course, it means that the less reactive metals, the noble metals, will resist bond with oxygen. Well, in fact, 3 of them do make bond with oxygen, but it's going to be a weak one. What's the meaning by weak? Later. But for now, we can think that gold and platinum, they don't make bonds with oxygen, which is very good. Okay. Now, that will be it for today. Okay. Key items here. There are two types of properties of metal, the physical and chemical properties. Okay. Physical properties is about the thermoconductivity, electrical conductivity, okay, malleability and ductility, melting point, and boiling point. Okay. Metal generally possess the first three: good thermoconductivity, electrical conductivity, malleability and ductility, okay, and they have high melting and boiling point, while non-metal is the opposite. Okay. And about the chemical properties, we need to understand reaction with three substances: ability to react with acid, with water, and with oxygen. Ability to react with acid, most metal react except the 5 noble metal. Reactions with the water or steam, only very reactive metals, groups 1 and 2, and not all of them, okay, they are going to react with water and steam. Reaction with oxygen, most metal except the very unreactive, gold and platinum, will react. That will be it for today. Thank you.